Okay, well, welcome everybody to the Web3 running a Polkadot Validator workshop. I think all of you here know who I am, Bill Laboon. Yeah, hello. So I am the technical education lead at the Web3 Foundation. Oh, can someone grab that? Thanks. Can you keep the door open to make sure people can get in? Thanks. So if you have any questions as we go through this, obviously it is a workshop. It's not just a presentation. So please feel free to ping me, ask questions. I'm sorry if you are online that you won't be able to do that. Also, if you're online, you will not be able to enjoy the pizza and cake that we have here. However, if you can make it down to Pittsburgh Code and Supply very quickly, I'm sure we'll be happy to give you to share some of it. But if you do have any questions, feel free to reach out to me on Twitter. I'm at Bill Laboon or bill@web3.foundation. Okay. So before we begin, if you're going to be following along, you may want to go to this gist. I have a tiny URL for it. Y2 Army J8. I didn't actually intentionally write that Army, but it is a nice a nice twist. It should make it a little bit easier to remember. So all of the commands, all of the links to information that we're going to run here will be available there, including links to back to these slides. So I'll give everyone a chance. I see some, if you want to write that down or at least go to that URL. That way you'll have all of the commands as we go forward. And please, help yourself to some pizza and soda. All right, so what is the Web3 Foundation? Well, the Web3 Foundation was established in 2016 to bring Web3 to life. Web3 is the vision of a decentralized and private web, as opposed to what we have today. It is located in Zug, Switzerland, and again, has been around since 2016. While Polkadot is one of the major projects that we work on, or that and that we endorse, there are a lot of other projects, a lot of other teams, a lot of other things we do that bring help bring blockchain technology to help bring decentralization to the internet. So as I mentioned, what we'll be discussing tonight is Polkadot. So what is Polkadot? Well, it's a heterogeneous, someone corrected me, it is not heterogeneous. I keep wanting to say like homogeneous, heterogeneous, but no, it's heterogeneous multi-chain technology. So if you're interested in more details, we have lots of information up at polkadot.network. But the basic idea is that we see the future not as a single blockchain and not as just all the data is out there entirely independently, but rather a variety of blockchains with different trade-offs that can communicate with each other. Because if you've used any sort of blockchain technology, there are pluses and minuses to using every chain, right? All software engineering in general is trade-offs. So there are some chains that are faster. There are some chains that's easier to develop smart contracts on. There are some chains that are more secure or more quantum resistant. There are all sorts of drawbacks and benefits to using any of them. And so the idea of Polkadot is that you would be able to decide which chain is right for you. Or even with Substrate, which we discussed in the previous workshop last month, if you should build your own chain because none of the ones out there actually meet your needs. However, with Polkadot, we can have these chains interact with each other, trading Bitcoin for Litecoin, or having an on-chain transaction that gets propagated to another chain, etc. So the basic concept of Polkadot is we're going to have one relay chain whose job is basically to shuttle these messages back and forth, allow governance at that level, and share the security of these parallel chains or parachains. So these parachains can be developed in Substrate. They don't have to be, but it's very easy for you to develop a parallel chain, a parachain in Substrate. And that will work out of the box with with the relay chain. It also will share security amongst all of these. So if you would like to build your own blockchain and use Polkadot, you will have to worry much less about providing security for your network because it's going to be shared with all of the parachains. Additionally, we are working on bridges to different other blockchains. So if you're interested in interacting with Bitcoin or Zcash or Ethereum or something that was not developed to be a part of Polkadot, you still can do that actually using bridges. So our idea, our vision of this of the Web3 is that there are going to be different blockchains, all of which have different trade-offs, and you can choose which one you want to use and yet interact with any other one via Polkadot. All right, so that sounds pretty good, hopefully, if you've ever used a blockchain. If you haven't, then just trust me, that sounds pretty good. So how do we do that? Well, we have our parachains running, and there are nodes called collators. These collators, their job is to provide basically a proof or a digest of what is happening on this chain. So we're going to have a full node running as a collator, and they provide a proof to our relay chain of what is happening on that relay chain and send messages to that relay chain. They're basically like a mini bridge between these two chains. On the relay chain, we're going to have what are called validators. So collators and validators work together to interact with all these different chains. Does this make sense conceptually? So we have on our relay chain, which exists to facilitate communication between networks, we have validators. And on those individual on those individual other chains, we have collators, which provide a proof to the validators of what's happening. So the relay chain itself is actually going to produce a blockchain which says everything that's happening, or at least a proof of everything that's happening in all of. All right, so let's take a closer look at the current testnet of Polkadot, which is running. And we can see what's happening on the relay chain. So if you go to this URL, again, there is a link to this in the gist that I shared with you, that tiny URL. I'm connected to my local node, which is not running, which is why it's showing there's nothing here, so I just got to save and reload. Click on Explorer. So I can see here, this is what is happening on our relay chain right now. So we are currently at block 2,134,557, and these blocks are being produced. Right? So each block in a blockchain, continues on from the last one. If you're familiar with blockchain, you're probably familiar with Bitcoin. In Bitcoin, blocks are generated about once every 10 minutes. With Polkadot, currently blocks are produced about once every 10 seconds. Obviously, there's a big difference here, right, in how often these blocks are produced. Another thing that we're going to discuss is that Polkadot does not have miners. Right? There is nobody producing wasted work in order to find a new block. Instead, we use a concept called nominated proof of stake, which we're going to have people validate that blocks are correct instead of again trying out different hash combinations and hash puzzles. So this is going to allow for reducing by many orders of magnitude the amount of electricity, storage, etc. That is going to need to run. So we'll discuss a little bit more about what exactly nominated proof of stake is and how it differs from proof of work. But just so you know, if you want to look at hashes, well, here you can look at hashes what we're going to do tonight. We'll also talk about, well, what if I want to do something with my dots, which are the token used for the relay chain for Polkadot, even if I don't want to run a validator, because as we're going to see, running a validator can be a difficult process and there are some risks associated with it. So let's step back for a second and look at how Bitcoin, for example, or many other chains that you're familiar with, such as Ethereum or Litecoin, generate blocks. So when you're developing a blockchain, like actually producing blocks for a blockchain, and by the way, these were actually taken from Bitcoin Block Explorer, so these numbers are actually correct for those specific blocks. What are you doing? Well, when you generate a new block, you need to make sure that when you hash all of the data in the block, that the hash value that is produced is less than some difficulty level, which is why you'll notice that all these hashes have a large number of zeros in the beginning. They're all very small numbers, right? So the goal of those machines that are, these Bitcoin miners, why you have all these miners just, trying out trillions. Actually, I looked the most recently, last time I checked, it was, quintillions of possible hashes per second. They're trying out different combinations of data, like different ways of arranging the transactions in a block, maybe modifying the timestamp a little bit, changing what's called the nonce, just some value inside, some 32-bit value inside the Bitcoin block, to try to make a hash that's very, very small. And once they've made one that's small enough, which again is going to take quintillions and quintillions of possible tries, because there's really no way, it's basically random. It's not actually random, but for all intents and purposes, it's random, of tries before you get one of these. Once you do get a small enough hash, you broadcast it to the network, and then congratulations, you are now the producer of this new block. And aside from giving yourself a warm fuzzy, that also gives you a chance to give yourself some Bitcoin. So when someone sends a transaction on the Bitcoin network, they pay a fee. There's also something called the Coinbase. So every time you generate a new block in Bitcoin, if you've done all of the work here, then you are allowed to give yourself currently 12.5 Bitcoin per produced block. It started at 50. It halves about once every 4 years. So this is why it's called proof of work. So if you've done a lot of work, it's probabilistic, but chances are, because it is generally random, the more work you do, the more blocks you'll be able to produce, which means that you will be able to produce more, more blocks and thus get more Bitcoin. However, we've already seen there are some downsides to using proof of work, right? For example, currently the Bitcoin network uses up about as much electricity as Switzerland. Now, there are a lot of arguments on why this is a good thing. For example, it has been, a lot of this electricity is being used with renewable power. You can say that, having some proof of work, make sure that really anyone can get involved as long as they're willing to pay for electricity. But I think we can all agree that, all else being equal, using less power would be good. Okay? So there are some, like I said, problems with proof of work, but obviously Bitcoin has been running for a little over 10 years now, so things seem to be going relatively well for it, but we think that there are some ways to improve it. So another idea that has come around, and there are all other sorts of ideas out there, like proof of authority, proof of space, proof of entanglement. There are all kinds of different ways to produce blocks. One of the most popular, that's been sort of the wave of the future for quite a while now, is proof of stake. So one blockchain that is technology that's out there and using that is Lisk. I took these actual blocks from the Lisk Block Explorer. So the idea of proof of stake is that instead of proving that you've done a lot of work calculating all of these hash values, you prove that you own tokens. So I can use internal tokens in order to say, well, I'm going to stake. I'm going to say, all right, these 3,089 tokens. I'm going to say I'm going to use these as part of my block production mechanism. I can't use them. They're sort of locked away. And then the network itself will randomly pick, according to how many tokens you have staked, whose turn it is to produce a block. So here, instead of spending real world electricity, you're spending these you're locking away these virtual tokens. And then some random function is going to go through and pick out who is supposed to be the next one to generate a block. So in a pure proof of stake system, the more tokens you have, the better your chances of winning. It's kind of like buying lottery tickets. So just like when you buy, if you buy 100 lottery tickets, well, you are more likely to win than if you bought 5 lottery tickets. If you've got 100 Bitcoin miners, like mining machines, as opposed to 2, you're more likely to get a block with 100. So in proof of stake, the idea is these lottery tickets are the tokens instead of actual real world electricity. Does that make sense of how proof of stake works? Questions? All right, so Polkadot uses a variation of this because there are actually quite a few papers out there on problems with proof of stake. In one big one that we saw is that here we can see the 3 little pig block over here has 16,000 tokens, right, staked. Whereas Juicy, I don't know how to pronounce that. Let's say Juicy, and Liber Spirita, they all have just a few thousand. So what's going to happen? 3 Little Pig is going to get more lottery tickets. They're going to gain more tokens as time goes by. So it's sort of what's called the rich get richer problem. So pretty soon, 3 Little Pig has tons and tons. That's an appropriate name, right? Has tons and tons of these tokens. Other people have none. Whereas with the proof of work system, anyone could use their computer or a Bitcoin miner or their GPU or whatever in order to generate more. So the other problem with proof of stake is in order to prevent some attacks, you have to have a way of punishing people. Right? So there's something called the nothing at stake problem, where because these tokens are virtual, if you just vote for everything, then whichever chain is real, when you're producing blocks, you just try to generate as much as you can. There's no real incentive to play by the rules. Whereas with Bitcoin, for example, with proof of work, if you don't play by the rules and other people reject your block, well, what have you just wasted? Lots and lots of electricity, which costs money, in order to produce that block. With stake, it's a little bit harder of a problem. And so there's something called slashing in a proof of stake system. So if you try to do something bad and the rest of the network realizes that you're doing something bad, I'm quoting bad. It doesn't have to be actually malicious. It could be any other kind of Byzantine fault, like you just getting offline or there being a bug in your code or something like that. You actually can lose some percentage of your stake. Right? That also seems a little bit scary. Right? So at Polkadot, we've seen that there's some problems with proof of stake. And so we have decided to use something called nominated proof of stake. So the idea of nominated proof of stake, it is a proof of stake system, but besides validators, which we've already discussed, they stake their own tokens, right? And if they do something bad, if they have any sort of failure, then they can be slashed. We also add this idea of nominators. So a nominator is not a validator. They don't have to run anything themselves. But what they do is nominate the actual validators. They can say, I'm going to put my trust in this validator over here, okay? And I'm going to let them use my tokens, right? To sort of to be a validator. So these are actual, like again, once again, real life items blocks that I got from the Polkadot block explorer. So we can see that this first block was generated by 5FZMF, the second one by 5GGG, the third one by 5F1. So 5FZMF, no one nominated them. They put up their own tokens, but no one is adding their own tokens, like saying, hey, I trust this person to be a validator. Whereas 5GG, two others have added some tokens to their validation pool, right? Their pool of DOT tokens. This validator, one person or one address has nominated them. So what this allows someone to do, if you are not interested in running your own validator, which we're going to cover tonight, but you still want to help secure the network, determine who's actually going to be a validator, etc., you can do that. So the second difference between, besides the addition of nominators to this, people who can stake their the dots without actually running a validator, is this idea of a validator set. And there is, once you are part of the validator set, all of the different validators involved in that actually have an equal opportunity chance to produce a block. So it doesn't matter if someone has 17,000 dots and they're a validator, and someone else became a validator with 10 dots. In that era, in that round of staking, they are each going to get an equal amount of dots. And I'll show you why that's important a little bit later in depth. But for now, you can just realize, well, that helps avoid the rich get richer problem. As long as I can get into this validator set, I will be making, my lowly 10 dots, I'll be making as much per round as that person with 17,000 dots. And this is also going to allow me to attract nominators that will keep me in the validator set. Because, again, we'll just discuss why that is in a little bit. But does this basic idea, this nominated proof of stake and equality, once you're a validator, once you're in the validator set, every validator for that round is going to get an equal number of tokens. Yeah, Robbie.
How do the nodes converge on an elected? How do they decide who wins the lottery?
So right now there is, and the particular testnet we'll be using tonight, it uses a CCF, what's it called, a coordinated coin flip. I feel like I'm missing the letter, but basically all of them produce values that gets hashed together, and by the end of it, that helps choose it does the randomness. Like every node that's already involved in the validator set produces randomness through this coordinated coin flip. Okay. There's a verifiable random function that will be coming in the next proof of concept testnet. I don't know the details of that VRF. I know it exists, and it'll be replacing our sort of, again, it has not been formally proven to be random, but it's one of those. It kind of works. So if you can look up a CCF, I want to say coordinated coin flip. It's if you're interested in the specifics of it. Yep. But again, that's going away very shortly with the VRF in the next version. Our researchers have recently, put the finishing touches on it. Yeah, Daniel.
So the proof of stake, you said by making it nominated, is eliminated the rich get richer, but don't you base the chances on how many coins still?
So no, so that's the second part of it. So the question, in case you didn't hear, and for the people online who may not have heard, is how did this really avoid the rich get richer problem? And so, I mean, the rich are still going to get more tokens because, or they're going to still get tokens. But once you're in the validator set, so right now, for example, it's the top 40 are validators. Let me go over back to the Explorer. So all of these validators Have another one here. This one only has 3. But each of them is going to get 10 dots, for instance. They'll all get n dots. So this is a much smaller percentage, right? The person that had 500 dots getting 10 extra dots, whereas suppose this person who has 3, well, if they get 10, boom, that shoots them up, right? That quadruples it, right? So the idea is, from a percentage perspective, you are actually going to be doing much better, right? And there's actually we'll talk about incentives when you're nominating on why you would want to do that. Does that make sense? So as opposed, if someone, let's say, had 16,000 compared to 3, well, now let's just make the math easy, right? So if someone has 9,997 tokens, someone else has 3, right? Well, in that case, let's say they're the only 2 validators. Well, out of every 9,997 blocks, validator A is going to be the one that produces that block. That's pretty centralized, right? Whereas here, if we had the same situation, it would be 50-50. Make sense?
Those are the validators, not the nominators.
Right. Nominators are just going to, and we'll actually nominate. I'll let you nominate me very shortly. So nominators are just saying, hey, I want back this horse, right? This validator. So instead of me making my own validator, I can just say, hey, I want to add, I trust this validator. I'm going to give them some tokens to validate on my behalf, like to give me more power. Or more dots, rather, not more power. Okay? So, present. Okay. So, these validators that I'm talking about, what do? Well, they are running a full node, a full Polkadot node. Okay. They're going to produce new blocks using our block production algorithm called Babe. Oh, thank you, Robbie. They're also going to help come to a consensus on what is the actual history. So if you're familiar with Bitcoin, you'll know that Bitcoin only has what's called probabilistic finality. There is no real concept of something that is entirely final in Bitcoin. Now, the chances that some very old block are going to be reduced are so microscopic as to, you would go through the universe billions of times, the length of the universe billions of times, and never actually reproduce this, but it's still probabilistic. And I will say, having talked to a lot of financial companies, this really scares them when they hear that the history of a blockchain is in fact probabilistic. So we have our own regular block production algorithm similar to Bitcoin using these validators. But we also come to a deeper consensus. We finalize the blocks using a different algorithm called Grandpa. So what Grandpa does, if you're familiar with distributed systems in general, this uses something, it's not exactly the same, but similar to practical Byzantine fault tolerance, where we can come to all right, this is the definition of the past. The problem with using PBFT or anything like that in a traditional blockchain, and some do, there are some blockchains out there, and there are definitely a lot of distributed systems that use it or similar algorithms, is that if it can't come to a consensus, so for example, too many nodes are down and it can't come to a consensus, it actually can halt the entire blockchain or halt the entire system. That's definitely not good. Right? So if we do have some sort of major problem, we actually can continue using sort of the classical way of producing blocks and just letting Grandpa, once things are working up and running again, come back and finalize. So it actually can finalize huge amounts of blocks in a very short amount of time. So this allows us to sort of get around, if you're familiar with the CAP theorem, it's not really beating it per se, but it allows us, even when there are major problems, we can still produce blocks and yet have a consistent and shared view of history that is not probabilistic. So if any of that doesn't make sense, just know that it's pretty darn robust. It allows us to have some, a real definition of immutability, that this blockchain will not change. So a big role of these validators that are running nodes is to validate the state transitions of the parachains. Remember that parachains are those parallel chains that are interacting with the relay chain, or traditional blockchains that are interacting with us via a bridge. So they actually accept, proofs that yes, this collator from the parachain or other blockchain just gave us an accurate idea of what and proof of what is happening on that blockchain. They're rewarded for helping the network. It's just like Bitcoin miners can get Bitcoin from mining new blocks. By acting as a validator, you will get additional dots, which are the token for the relay chain. And if you have a failure, either you're cheating or you're offline, then or just miss something or provide an incorrect result, you're punished for this. You're what's called slashed. So there is a risk to running a validator, and you definitely want to make sure that you are running it well, that you have you're using good security, that you're making sure that you have backups, etc. So there is a risk from being a validator. Although this is similar to the risk of running a Bitcoin miner, right? Theoretically, I could run a Bitcoin miner for years, even if I have a very large set, a lot of hash power, and never actually get a block. So similar idea. You could have problems, use up a lot of electricity, but you have a network failure, and not be able to continue. So in here, with proof of stake, though, you have to be punished a little bit for it. Nominators, they don't have to run their own node. As long as you have an address and you have some dots associated with that address, you can nominate someone to be a validator, which is going to increase the number of dots that they have in order to become part of the validator set. So you can also stake your dots, and you will also be rewarded or punished if the validator that you nominated produces good blocks, or if it's malicious, incorrect, offline, etc. However, as a nominator, generally your rewards will be less because the validators can actually, they're going to take a cut first before handing it out to their nominators. But you also will be punished much less in case there is a failure. But the goal is we want people to think about who are they nominating to be a validator. Right. There are other systems such as Nano, which uses delegated proof of stake. So you don't have to, you're in no danger. You can just give, just whatever. I want you to represent it. You look trustworthy. Here, have some Nano to represent me. We really want you to think about, before you do this, before you nominate someone, are they good? Do they have a good history? So they can't actually take, if you bond as a nominator, they can't actually steal your dots, but you could be punished if they end up being malicious. So we already mentioned in sort of a talk with Daniel's question that only the top N validators. So right now I believe it is 40. They may have changed that number slightly. 46. Okay, so we have 46 actual validators that are part of the validator set. And remember that they will share equally in the rewards. Okay? So it doesn't matter. As long as you've gotten into the validator set, you're good to go. And you will each get an equal share of the rewards for that session. You can see we've got here some people who are signaling their intention to be validators. They want to get in, but you'll notice a lot of them, they don't have quite enough dots yet. I see a lot of validators with 100 millidots or 300 millidots. So it's going to be the top 46. We'll get there. And it'll recalculate at the end of the session. Yeah?
How do you get more dots if you're not elected?
So how do you get more dots if you're not elected? So you can buy them. You can be given them. This is the way that more dots are actually produced. But there were people that bought dots in the pre-sale, so they'll get those. There'll be another sale that you'll be able to buy them, or just buy off an exchange.
So dot is like the name of the coin, basically.
Yeah, we don't really think of them as coins per se. They're really like governance tokens. But dots allow you to do things. So if just like Ether, right, it allows you to do things on the network. So dots are going, anytime you send a transaction or communicate, that's going to cost dots. It's going to cost you to do something. It also is, but again, instead of doing that with them, you can stake them.
Thank you.
Yep. You can get kicked out of the validator set. If someone else has more dots, then if you're the lowest number in the validator set, you can get kicked out. You can actually say, hey, when you first sign up to be a validator, hey, kick me out in case you find me acting inappropriately 3 times. Because let's say that you know that you may have a faulty connection, like, oh, I'm on AWS East and that's had problems in the past, or hey, I'm just running this off my local machine at home, and my UPS is flaky. Well, you can say, for example, hey, if you find me not online 3 times in a row or something, just kick me out. There's probably some major problem. I'm away for vacation. I don't want you to just keep kicking me down until I have 0 dots. Okay? So people go into, or validators rather, they're not. What do they say? Don't anthropomorphize computers. They hate that. So validators will go in and out of this validator set. It's not set, eternally. So should you stake? Which either you actually run your own validator or nominate. So as you're thinking about this, a lot of people they think, well, what can I do with dots? I could stake them. There are other things you could do, as I said, to run or run transactions or interact with parachains, etc. All these cost dots. So there's other things you could do with your dots. So should I stake? Well, there are some pluses and minuses. Everything in the world is a trade-off. So what's some pluses? Well, it allows you to generate dots. It's like getting interest. Okay, so if you get in the validator set, either your validator that you nominated is in the validator set, you can get some additional dots. That's great. Everyone wants more dots. Okay? It's going to allow you to understand the system better. You'll be using it. And of course, it helps you secure a decentralized Polkadot. Now, I understand most people don't do things just to help out Polkadot. So I'm sure this is sort of what everyone's looking at when they want to know why they would run a validator or nominate. But of course, there are cons. Your dots are locked while bonded for staking for approximately 12 weeks. We're still adjusting the parameters, as I've already mentioned. We're still in the testnet phase. Mainnet is coming later this year, but approximately 12 weeks. So if you're thinking, hey, I might need to use these dots for something else in the near future, well, maybe staking isn't for you. And of course, there's a chance of loss, right? If you choose a very bad validator, you can actually have some of your dots slashed. So we really anticipate there to be a market and perhaps perhaps different rating agencies for all right, this validator has done well in the past, or they have this many dots, etc. Yeah, Daniel.
Do slash dots disappear, or do they go to some other entity?
So the question is, what happens to slashed dots? I believe they are going to be burned in mainnet. I'm not 100% certain of that. I know you will lose them. I'm not sure if they go. I'm pretty sure they don't go to fees. I'm pretty sure they're burned. Which, if memory serves, I have to reread the paper because that's good. Otherwise, there are some what do you call it? Perverse incentives. Thank you. Where you could try basically to get somebody offline or perform some other failure in order to get their dots. If they're burned, that's from a game theoretical perspective, works the system a little better. All right, so if you've decided that you do want to stake, well, should you nominate or validate? All right, once again, there are trade-offs. Again, if you've taken software engineering with me, you're probably sick of me hearing say, well, there's trade-offs to doing this or this. I say it all the time. Software engineering is just trade-offs. Anything in software, it's all trade-offs. So if you validate, well, there's opportunity for greater returns. You are the one who decides how to share your dots. You can take a cut for yourself before you give any to the nominators. You don't need to rely on others to validate. It's similar to like you're running your own node, your own full node in Bitcoin. Basically higher risk, but also higher reward, right? If you nominate, well, the big benefit is you don't need to run a validator, right? Which again can be a problem. So Cosmos, which is a similar technology, they estimated something like $30,000 to. I may have the number slightly off because I'm just remembering off the top of my head in order to run a validator. Right? Not everyone has $30,000 lying around or is willing to risk their money for that. But it's much less work. We're all busy. We have other things to do besides babysitting machines. It's lower impact in case of slashing, and generally less risk but less reward. So if we think of validators, that's more like from a financial perspective, that's the stock market, right? Or maybe investing in Bitcoin, very volatile but chance of very high rewards. Nominators would be more like certificates of deposit or bonds. You're not going to shoot up, but you also know you're much less likely to go all the way down. All right, let's look at how these validator pools work. So remember, we had 3 validators. So I just grabbed these off three blocks that I found, who their validators were. Although I made up the specific number of dots just to make the math easy. Do you remember validator 1? There were no nominators, but the validator themselves staked 10 dots. So validator 1 staked 10 dots. Validator 2 staked only 5 dots, but their pool total is 12 because 2 nominators have added some dots to that. So you see one nominator added 1 dot, a second added 6. So they really believe in validator 2. Validator 3 has 20 dots, and 5 Cable has nominated them with 10 additional dots. So we can see, just add up, right? How many dots are in the validator pool? 10 plus 0 equals 10, 5 plus 1 plus 6 equals 12, and 20 plus 10 equals 30. But remember that the rewards, so let's say the rewards for this block are 10 dots. Validator 1 will get 3.3, validator 2, 3.3 repeating, right, down to the limits of down to the limits of the dot partitioning. 3.333, 3.333. So what's that mean? This person got about 10% additional dots, right? 30, a little over 13, whatever, 10-ish%. This one got an additional like 25%. 12 they got 3, they dropped to 15, and they got like 30%, right? So assuming that they share equally with their nominators, right? Just to make the math easy, we can see that, well, all right, I just staked 10 dots and I got a 30% return. I staked 30 dots and I got a 10% return. So, who would you rather be? So again, they're all equally likely to produce the next block. So this is how proof of stake works. So we have some sort of randomizing function. Again, right now it's using CCF. It's going to be using a verifiably random function starting with the next testnet, which is coming soon. So anyone can be a nominator. Only a limited number of people can actually, or validators rather, can actually be in the validator set. So here, let's say we just have 3 people. I don't know why I keep anthropomorphizing. There are only 3 validators that can be here, okay, that we can choose from. Let's just like imagine that going forward. So you get your rewards calculated every session, which is about once every 5 minutes. Rewards are paid out every era, which is approximately every hour. Again, it's not exact. It depends upon network latency and some other things. We then so let's say that we split up our dots equally among the nominators. Okay, so this. Let's say, again, just sort of to make the math easy, these aren't very realistic numbers now that I'm looking at them. Stake 5 dots, you get 100 dots in rewards. So the validator says, all right, for my job of being a validator, I'm going to take 40 dots before I give my nominators anything, right? Because I need to do, I need to keep the server running, and I need to make sure it's always up, and I've got the extra stress of actually being a validator and producing blocks. But after that, with 60 remaining, it'll share with its staked dots, right? So it'll get 25 dots. With 5H4, who just staked 1 dot, they'll get 5 dots. And this person who bonded more actually gets 30 dots. So we can see here from a nominating perspective, there can be a difference, right? But from a validator perspective, it's going to be equal in terms of dots given. Yeah, Daniel.
So when you're nominating, the validator will be upfront about what the proportions will be?
Yes, you're able to tell ahead of time. Yeah, so, I'm sorry?
Then you would pick based on that.
I can't hear you. But.
Sorry, you would nominate a validator based on that information.
Right, so the question is, yeah, all of this information should be given to you up front. It will be given to you up front. And that is some of what you can look at to make sure you know, wait, who should I nominate, right, to be a validator? Who can I trust? All right, so this brings us into the next question. Which validator do I nominate? Should I just pick one at random? Let's say that everyone, again, just to make this an easy understanding, let's say they're not taking any validator reward, they're just running because they love to run, and they're going to equally share with everyone. Well, let's say I've got some dots that I want to stake. Well, should I nominate validator 3, I'll be a much smaller portion of their pool, or validator 1, where I'll be a very large portion of their pool? Well, all else being equal, if we go back to here, it makes more sense to nominate validator 1. Why? Because let's say I add 5 dots, I nominate with 5 dots. Well, now that means I've got a third of the of validator 1's validator pool. I'm going to get a huge percentage of that equal gain. Whereas with validator 3, if I add 5 here, they've got 30 dots. So that's 5. That's like 1/6. So I'm going to get a much smaller amount of that fixed size. So I'll get higher rewards by nominating validator 1 and less rewards by nominating validator 3. All right, so why is that important? So again, all else being equal, assume that everyone is we're all just being equal. There's no reason, it's not like I'm buddies with validator 3. Then all else being equal, we want to encourage people to spread out their nominations, right? Don't have one person that has all the dots associated with them, right? So we actually add an incentive to nominate, again, all else being equal, a lower staked validator.
Sorry, isn't it 3 times more likely that validator 3 will be elected than validator 1?
No, so that's the difference between our proof of stake and something like Lisk. So once you're in the validator set, any validator is equally likely to produce a block.
Understood. Thank you.
And they also get an equal amount. So there is a target or a threshold you have to reach in order to get into that set. But once you're in there, then everyone is equal.
Thanks.
Yep. Right. So we can see why if they're all going to get the same block rewards, they're equally likely to produce a block. But if I nominate validator 1, I get a lot more dots. More is better than less, right? But of course, in the real world, nothing is ever equal, right? So there might be a reason that validator 1 doesn't have any nominators. Right? It could be they've been malicious in the past. Or, oh, I know that validator. That's done by whatever, the same people that put that backdoor into Zoom or something, right? There could be a reason people don't want to nominate them. They could be a bad validator, right? And again, we want that to be expressed via the market, that people are going to not want to use that validator, right? If they have been bad in the past. So eventually, their validator pool, they'll drop or they'll get kicked out of the validator set. So once again, we can see there's sort of a game theory aspect to this, where you're going with let's say a really good validator, lots of people have nominated them, they've been online and everything for a long time and without any problems. Well, you're going to get less rewards for doing that. But let's say like validator 1, I know they look evil, but it's not really, right? Just because they're purple and have horns and angry eyebrows, right? Then I, may say, well, if I know that they're good, I'm willing to sort of put my money where my mouth is, right? Put some skin in the game and nominate them. Again, it doesn't. There could be other reasons. They don't have to be malicious. They could just fall offline a lot, right? That's my sick validator, right? So there's lots of reasons that people might not be nominating. Okay? But we want to encourage as much as possible an equal spread of dots and punish those who are not operating the system properly, either because of maliciousness, malice, I guess, either through malice or just through incompetence, or even just plain bad luck. If their network is down or something, we don't want them to be part of the validator set. Because remember, why not just select validator 1 if you know that they're going to be bad? Well, 1, they may get dropped out of the validator set, in which case you're not getting anything with those dots that you bonded. You're also missing out on the ability to actually get dots from some of the good validators. And finally, you could lose some of the dots that you staked. Again, if you're a nominator, the punishment is much reduced compared to being a validator, but there still is a punishment. You can lose some percentage of your dots. So if you're curious, this is what we're looking at. Again, mainnet hasn't been released, so these numbers are subject to change. But basically, we have 4 levels of slashing of the validator. So if a validator is something that is probably accidental, just 0.1% of the stake gets slashed. This basically moves up orders of magnitude. So if they can't ping you for a while, all right, 0.1% of stake slashed. If there's some evidence of bad practice, right, that you're just incompetent, you're not setting this up correctly, up to 1%. Misconduct, which is likely to be malicious, up to 10% of your stake slashed. And finally, misconduct, which has a serious risk to the system. If you see multiple validators doing something, you can actually have all of your stake slashed. Yeah, I mean there's nothing stopping you from doing that. You could then you would then have to spend dots though on running those other validators. But yeah, I mean there's nothing. I don't know who 5FZMFE is versus 5GGWN. These could be the same person running multiple validators, but each validator is their own node.
They are 1 and 3.
What's that?
1 and 3 are the same.
I think that's a copy paste error. Let's see. No, maybe it was the same thing. Someone nominated, or maybe it's a copy paste. Sorry. No. Yeah. I think that was a copy paste error when I was making the original slide. Sorry about that. Thank you for catching it. You should file an issue. Yeah, submit a PR. PR's accepted. Okay, so there's another node I want to talk about briefly, fishermen. And I know it should be like, fisher people. But a fisherman is another kind of node which monitors the validators. Right, so you can tell my beautiful art here. So a fisherman node stakes a small amount of dots, and then what they do is they're like the cops of the network. So they can accuse the validator of cheating, basically, of proposing a block that doesn't make sense, and if they can prove it, which they should be able to, they are highly rewarded. Okay? The malicious validator highly penalized, and they will. So unlike with some of these other issues where the slash tokens are burned, a large percentage of those tokens are actually given to the fisherman. So this provides, again, the who watches the watchmen, right? It's extra nodes that come in and they're just looking for anyone to cheat, and if so, they can get rewards. Yeah.
Yeah. Sorry if this question is based on a misunderstanding.
Yeah.
But it seems like in terms of like those variable levels of punishment for the validators,
mm-hmm.
and also for these fishermen, that this blockchain sort of relies on like humans and game theory. So then another question is, who watches the fisherman? And could a validator like become a fisherman while he's a validator and like allow himself to engage in corrupt practices and questions like that?
Oh, so that's a good question. What he said was, what prevents, for example, a validator becoming a fisherman? What is the? It seems like there's a lot of human aspects to this, and I've sort of been describing it at a very high level. Actually, all of this is happening sort of mathematically, right? So when I say that someone is, for example, cheating, or we can actually look at like the cryptographic hashes and like the proofs that were actually provided and determine whether or not they were correct mathematically. So this can all happen automatically. So a fisherman node, for example, is not some person looking and seeing that something's wrong. It's actually like sort of going through the network and verifying things mathematically.
Okay.
All right. So let's go. So does this make sense? Like nominated proof of stake, why it's good, how it works, what a validator is, what a fisherman is. All right. Okay. We're running a little bit low on time, just because we started a little bit late. So let's take a look back at the our block explorer. And again, you can follow along polkadot.js.org. So what does all this mean? This is how many seconds it's been since the last block on the Alexander testnet. We're targeted at 6 seconds. We have issued so far 999,225 dots to the validators. Our session is basically 50 blocks, every 50 blocks. That's when our rewards are calculated. They're given to the validators. And an era, about once per hour, is again once excuse me, about every 600 blocks. That's when the rewards are going to be paid and new validators selected. So we can see that there's finalized and best. So remember I said that block production is actually separate from finalization, of like verifying that this is the canonical blockchain. So best is actually what is the latest produced block, and then finalized is, all right, what has actually been finalized, and we've said, yes, this is definitely it. Okay. And again, they're running using separate algorithms, which allows us, if there is some major problem with the network, we actually can continue on, even if it won't be finalized. But once that those blocks aren't finalized. But once enough nodes come back online, it will very quickly. Grandpa is actually a very, very quick finalization algorithm, and can do thousands and thousands of blocks per second on normal hardware. All right, so if you're ever interested in like looking at what is the Polkadot blockchain doing, you just go to polkadot.js.org, Apps Explorer, and check it out. So we are going to go through some of this. So even if you didn't get the software to be your own validator, if you didn't we'll work through that. But if you haven't installed Rust, you may want to do that now. We can just use polkadot.js.org and actually nominate. So again, being a nominator, very, very easy. All you have to do really is make some accounts. So if you go to polkadot.js.org/apps/pound/explorer, go to settings. We're going to do everything on the Alexander testnet. I wanted to do that. I wanted to do this on a local network, but I had some problems setting up earlier today. But this will be cool. We're doing it on the real testnet. So make sure it says Alexander. Make sure it does not say Emberic Elm or local node. All right. So is everyone able to do that? And then go to Explorer and make sure you're seeing approximately this number. Is there anyone that's trying to do it and having problems? Is it? 1 second.
How do you get off of That's right, Polkadot.js.org. I know you're doing this. Apps. There you go. Right. Everyone else good? Grab some pizza while
we'll just watch this, go by for a while. All right. And we're going to want to add some accounts. All right. So if we go to add accounts, add account. So I've got a couple of different accounts here. And these account names, they're just local. So don't worry, you're not going to have to worry about someone else having this exact same name. And we're going to add several accounts. So in order to nominate, we're going to need 3 accounts. This is kind of weird, I think, but it's going to make sense. So we're going to give ourselves 3 accounts. What I like to do is just give them a name, then one with stash, one with a stash suffix. So like here I had Mario stash, a next one with controller, and the next one with session. So make the stash one first. We're going to have to slightly modify things after this. So let's make sure everyone can get stash working. And before you save it, copy down the mnemonic phrase somewhere. So that it's going to say mnemonic seed. So here it says clerk column spare. You'll want to save that somewhere. That's basically your seed. So if we go here, add accounts. So I'm going to Coupa stash, my mnemonic seed, divert, organ, robust, etc. So here's my Coupa stash. And the address. So if you click where it says plus, it'll automatically copy it for you. The UI is a little bit weird. It tells you over here address was copied. So you're going to want to know your address and your seed. You do not have to use Emacs. If you're a Vim user, feel free to use Vim or whatever text editor you like. Give it a password. I don't really care about this. It's testnet, so I'm just typing in password. So in case any of you are elite hackers, you can try to get into my system here. The key pair, make sure it says Schnorkel, SR25519. So this is a particular cryptographic type. It's elliptic curve. We're using this particular curve. So we actually need to store with two different types of cryptographic curves. So this one is going to be Schnorkel. So hit save. Create a backup account. This is going to just like download a JSON file that you can load back up into the UI. All right. So was everyone here able to make a stash account? Anyone have any problem making a stash? All right. So the next step. What I'm going to have you do is if you go to the gist that we talked about, I'll post the tiny URL because I know a few people came in late. So tiny URL /y2armyj8. Is everyone there? Okay. So what I would like you to do is get your address, not your key, the address. This is publicly. Don't share that with that key with anyone. That is your secret key. Again, this is a test net. It doesn't really matter, but it's good to be keep good security in mind. Your key, those words, are basically the equivalent of a very large number, which is your secret private key. Not exactly, but it's definitely private. Don't let anyone else see it. But take that address, so that the number that starts with 5, large string that starts with 5, go to the gist. Oops. And leave. Oops. You should be able to leave a comment at the bottom. Thank you, Robbie. You read my mind. So just put your address in there, and in a moment, while you are all generating the other accounts that you have to create, I will send you all a dot. So you will all be the proud owners of a testnet dot. Yeah. Yeah. It's very, very exciting. Yeah, so I'll send you over some. Let me see if I got my... Yep. So you're going to want to create 2 other accounts. Where was I? So a controller account and a... oops. Typo. Sorry. Session. No. Wasn't a typo. I'm going to deal with session in a second. Okay. So now do the same thing. You've already created a stash account. Do the exact same thing to make a controller account. Make sure to write down your secret key, your secret seed, and your address. You don't need to share that with me. You're just going to give the stash. Okay. So you're going to need a stash and a controller account. They can't be the same thing. The stash account is where you're going to store your dots. So the nice thing about this, it can be very secure and held away. The controller is an account that's just going to turn your staking off or on. So create a controller account. And I'm going to start, and once you get some dots, keep most of them in your stash account, but put a few millidots, like 20 millidots or so, in your controller account. And I'll show you how to do that in a second. So you go to transfer. Say, from account, so there's my Coupa stash and I would send it to some other account like Koopa controller or Mario controller. So 20. And note it starts with dot. You're just going to send a few millidots. So you'll pull down here to milli. Oh, and we're going to need more than that. Oh, right. Koopa doesn't have anything yet. Let's give him 200 just to be fun. We'll flip back and forth a few times. So 200 millidots, which means you'll have about 800 millidots, something like 797 millidots left in stash. All right, so I'm gonna make another account. Koopa controller. Copy and paste this to my Emacs. This can also be Schnorkel. All right, so now I'm going to send some dots to my two, and then I'll start sending them out to you all. Well, actually, I've got some. Yeah, let's. So from Bill 2 to Koopa controller, send 200 millidots. Oops. Sign and submit. So whenever something is happening, you'll notice you get like your information of what's happening over here on the right. When you see extrinsic success, that means that you have, whatever you have tried to do has succeeded. So I'll put in a 800 millidots in Koopa stash. We'll see once a new block comes that this should. All right, extrinsic success. Okay, so is everyone able to make their controller and stash accounts? All right, so I'm going to start sending stuff over. Oops. And then, like I said, once I give you put your stash account here, and once you get your dot, please move, let's say 200 millidots into your controller account. I've got a.
So.
I'm sorry?
For controller and stash, it's not a setting in there. It's just something we call it ourselves.
Yeah.
Okay.
So they are different, and we're just going to use them. But just to make it easier later, we decide which one's which. All right, you got it? Seeing it? All right. All right, the Obama, you're next.
How many millidots?
You should get 1,000 millidot, one dot. So.
How many to controller for transfer?
Like 200 millidots.
Thank you.
Yep. All right, Jam 1015. Sari Berry. Rehashed Prime. What's that? Ere.
Yeah.
I feel like I just have such a boring GitHub name.
Dude. I mean, I feel like just to be on GitHub is cool enough.
It's the problem with like I've got such like an unusual last name. It's always very easy for me to just get whatever service I want. So I always just put in Laboon. All right, I think that's. I'm sorry.
I've been using Rehash Prime for a while now. Like I don't know, like 8 years ago.
Oh wow.
Yeah, dude.
All right. Anyone else not put their address that once the testnet dot? All right. So again, move like 200 millidots over to your controller account. So just click on your account that I sent it to, your stash account. Hit send. Put in your address. You can also add it to your address book if you want by clicking on address book if you feel like you're going to do this more often. And then 200 millidots. All right. So we now have our stash where we're storing things and our controller account. So now what we need to do is actually stake our dots. Okay? So as you might anticipate, we're going to press staking. And we can see here's the validators and validator set, and here's the people waiting to validate. And you can see I've got some already up here, but what you're going to want to click is new stake. So you'll notice to nominate, I just need 2 accounts, Mario Stash, Mario Controller. So I'm going to make a new, oops. So you can see why I like to say stash and controller as part of my name, because it asks me, all right, what's the stash account? What's the controller account? And I say, Koopa Stash, it's a stash account. Koopa Controller, that's a controller account. Value bonded, I'm going to say max, because I am just to the extreme. Right? So aside from some fees that I've already spent, you can see I've got 797.5 millidots left. I can also decide, what do I want to do when I get money? Do I want to send it to the controller account? Do I want to increase my amount at stake by adding to the stash account? Send it to the stash account, but don't stake it. We'll just increase the amount at stake. And then click bond. Oh, yeah. You can see my validator got reported offline. Probably as I was setting this up for this. All right, so you may have to refresh to actually see this. Yep. All right, so do you see something that looks like this with set session key or nominate? Anyone not seeing that after refreshing? All right, so now, whoops, no. I forgot, I'm not using. Okay. So now we saw extrinsic success. Now we need to nominate someone. So who should we nominate? Well, feel free to nominate anyone. I'm going to run my my validator here. So I'll ask that you nominate me, but who am I? I'm not going to judge if you don't want to nominate me. Where was it? Shoot, which I had a whole bunch of tabs open and now I can't find it. There we go. All right, so I'm going to have a validator called Bill Laboon. So, and you can run your own validator in a second. We'll cover that. So again, my node here. All right, so now because I was offline, I shut this off earlier when I was setting up. I'm now synchronizing with the network. You can see syncing 61.3 blocks per second, syncing 59.9 blocks per second. Okay. So I'm catching up. I'm at block 2.13 million or so. But now, let's go here. I'm gonna. I have asked basically. I want to be a validator with Peach Stash. So let's see if we go to staking. My account actions and my Koopa stash. My Koopa wants to nominate Peach. All right. So my controller account, my stash account. What address do I want to nominate? Here are all the different addresses that are possible. Let me get my Peach address, which was up here somewhere, Peach. Oh, it's in one of my... Of course, now I can't find it. It's in one of these terminals. This is the problem with having too many terminals open. There we go. So my Peach session, we haven't done a session yet because we're just nominating, but this is my validator. Oh, it doesn't like that. I guess it's not. Oh, because it's not synchronized yet. Well, I'm just going to pick one random one to nominate. All right. So now I'm saying, let's refresh this to make sure we're up to date. So I am now nominating 5GN bow. Okay. Let's give my my validator time to sync. Although I can't. I've now bonded those dots. They're kind of stuck with that validator. So feel free to nominate anyone you want. Again, if this were real money, you would probably want to see, all right, who is this, right? Not just pick a random one. How much are they offering me? How much are they? Have they been down in the past? Have they been slashed before, etc. I'm sorry? Oh, I was going to wait until the very end. Sorry. I know it's tempting, isn't it? It is so tempting. Yeah, and you're right in front of it. All right, so let's hurry through. I know we're all yeah. Well, we'll have cake while we ask questions. How about that? Okay, yeah. So you should see staking nominate finalized. All right. So to be a nominator, all you need are dots. If you want to be a validator, you need to get a little bit more in depth. So not only you need some dots, you also need a server, another key, another account called session, which uses another curve called ed25519, Edwards 25519 curve. Make sure you're storing the mnemonics away for this. So in order, so I'll just show you, because I know like ahead of time we had a lot of people having trouble with getting all the Rust prereqs installed. But the instructions for running it are all online. So I'll walk through you and show you what's on my validator and how it works. But you're not going to be able to actually, you'll see how to run a validator, and I have the instructions there for doing it. But I think we're running out of time. We're going a little bit more slowly than I did in the practice session, so apologies. So there's a separate key, the session account, so remember, stash stores your dots. Controller turns it off and on. Session is actually where you're going to do the work of validation, actually proving proving the proofs that come from the collators and generating these new blocks, which is why we need to use this special other kind of crypto. Okay? So if you remember before, we had set session key or nominate, and I said to press nominate. But if you're interested in validating, you can add a session key, add a third account onto here. So if you were able to get the Rust commands and had Polkadot compiled, you can now run your own validator. Polkadot chain Alex / --validator -- key equals your session key mnemonic. You will get an error if you didn't use ed25519 but used a different one. And a nice name to see yourself in telemetry. So, name Bill Laboon or whatever. Telemetry, in case you're curious, if you go to telemetry.polkadot.io, I'm not, it's often hard to find. What name did I give myself here? Bill Laboon. Let's see. I should have given myself an emoji. It's usually easier to see. Oh, here we go. Bill Laboon. Once you click, I'll stay at the top. All right, so we say, hey, where am I? It's kind of hard to see. It says Pittsburgh. All right, so I've got 416 millisecond block propagation time. Right, so it says that I'm attached to the network, and I can see some information about me and some other nodes. See people in Portland, Singapore. Dash is a very popular place, apparently. Washington, LA, Piscataway. Interesting. Sent at the end. Yeah, we got people all over the world running validators here. Quite a few validators or potential validators or other nodes running on this network. All right, so now my validator, I'm not yet in the validator set. Okay, so until I sync up entirely and until I've been chosen to be in the validator set, I may see some warnings like, hey, you're not quite ready to be a validator yet. Yeah, so that's what this. It's kind of hard to see. Unable to start parachain consensus, right? It says, hey, you're saying you want to be a validator and do parachain consensus, but you're not a validator at this block. So it tells you this repeatedly until you're chosen to be part of the validator set. If you look at the logs. All right. So if we go back to the Polkadot Explorer, we can see here I have already set my session key here. As you can see, Peach session here. I don't need any dots in that. I keep all of them in stash and just a few in controller for running commands. Automatic unstake threshold. I'll say 5. I like living dangerously. Validate. So now I'm signing up to be a validator. That doesn't mean I'm going to be one. I've signed up. I got kicked out of the validator set earlier because I wasn't responding. So if I go back to staking overview, I should shortly see myself in the next up. Yep, there I am. And it's saying, hey, you were bad before, right? You were offline. You see, I've bonded 2 dots. Right, so after a while, I will get on to the validator set, hopefully. Why is this not presenting? Sorry, I pressed the wrong button. So we already did this, right? How much you can say how much you want to take as your commission for running a validator at the bottom. So you could say, I'm going to take whatever, 100 dots, as much as I can. Or say 0, just let whoever nominates me, we're all in this together. I'm just running this validator, for my own sake. Automatic unstake threshold, when do you give up? So like I said, I'm now in that next up until the era is over, and then it's going to say, hey, who else is going to try? Has anyone else made the leap, to get into the validator? So at the beginning of each era, I might get into the validator depending on who gets kicked out, and then I will get to validate and add blocks until I get kicked out by someone else, or I go offline too many times or anything. So while we wait for that to happen, hopefully it'll happen relatively soon. What do you say we cut the cake? I know people, yeah, people have been waiting for that. We can ask if anyone has any questions.
I have one burning question.
Burning question,
You said that it would cost $30,000 to run a validator. Why?
So let me get back to here so people can hear. Actually, do you want to? Someone want to start cutting the cake while I answer questions?
Yes.
Yeah. Go ahead. Yeah, do it. So the question was, why would it cost so much money to run a validator? So that number that was from Cosmos. So that's not what we're saying for us. I just want to clarify. But one, you have to have a lot of dots, right? People aren't going to trust you if you don't have money staked, behind this. So it's, again, your stake, your money, what you have bonded is the equivalent of, like proof of work in Bitcoin. It's what you prove that you have some skin in the game. So one is the large amount of dots. You don't need an extremely beefy computer, but you're going to need a backup. You'll probably want to store at least your stash key on some sort of hardware security module, right? So that's going to be several $100s. Paying for the computing power, the backup, data center costs, etc. That all adds up. So the estimate that they have for right now is about $30,000. Again, I may have the numbers slightly off, but it's in that general ballpark. But the majority of that comes from having to stake your own money. So if I say, hey, I'm going to stake $1, okay, which is not that much. But I want all of you to nominate me. I want you to trust me with 100 dots. People probably aren't going to trust you. So what Cosmos has seen for getting into their validator set and for running a node, the approximate cost is $30,000 once they've added up everything.
That's $30,000 startup cost.
Yeah, I'm not sure of the ongoing maintenance. What's the word? What's the opposite of capital expenditures?
Oh, no.
Operating expenses. Oh no, yeah, thank you. Yeah, you can see I'm not a business guy. But I'm not sure of the exact numbers off the top of my head. So we're talking order of magnitude, not we expect it to cost this much, but it will cost money to run a validator. Yeah.
So I'm fairly new to blockchains, and quite honestly, I have a client, liberation artist, and they're looking to create their own blockchain. They want a system that's very similar to the Polkadot system, right? My question is, is this system set up for just sort of like test benching and sort of getting the idea of how blockchain works, or would it be practical for an enterprise or small startup, nonprofit like Liberation Arts, to go ahead and get on this platform and try it and run this as their way of trading their digital goods?
So the question, just for people online or who may not have heard it, was would this be an appropriate platform for a smaller company that is interested in blockchain? If I get it right, yeah. So remember, Polkadot really is this whole broad conception of blockchain, right? There are lots of different blockchains that can interact with each other. Depending on what they are interested in doing, it may make more sense to simply make a smart contract on an existing blockchain. And we do have some smart contract focused blockchains on Polkadot, such as Edgeware, which is just starting up now. Or they could make their own blockchain and use shared security. So basically use the security of this larger Polkadot environment to make their own blockchain if they think that a specific blockchain is what they need. But this definitely, it's very easy to fool around with. And I think you were at the Substrate talk last time. So you can use Substrate to just generate a blockchain without interacting with Polkadot relatively easily, as we saw. Or if you're interested in doing something specifically interacting with other blockchains or sharing security with them, we have a testnet. We have a, in my opinion, very excellent technical education team that is willing to help out to understand the testnet and build on the testnet. We have numerous teams working on testnet projects right now.
Okay.
Some of which are very small, like a few people.
So 300 local artists, right? All of them uploading their digital goods, their arts, their digital prints, their drawings, their mediums, all online in PDF or PSD format.
Mhm.
You know, I'm assuming the idea of you and use of the owners of Liberation Art is that they can create their own blockchain and use it as a subcurrency as opposed to PayPal or anything else for the artist and for anyone else interested in the Liberate Arts community. That's the tie-in to what Polkadot is about.
Yeah. So the question was, could this small like artist collective use their own blockchain, interoperate with Polkadot, and have their own currency on it? And the answer is yes. That's specifically what Substrate is. Is a very easy implementation to make with Substrate to do and interact with Polkadot.
Good to go. All right.
Yeah,
Thank
and I'm happy to we can talk more offline about if
Yes,
they're
please.
looking for something specific.
I would love your email.
Yeah.
Just to sort of follow up with you as I go down this rabbit hole for sure.
Yeah. So if we go.
To the tiny hero out.
Right. Well, no. Well, we just go to the next slide. So you can feel free to follow me on Twitter at Bill Laboon or Bill at Web3.Foundation. I'm happy to answer your questions or put you in touch with the right person. Who would be able to answer them.
I appreciate that.
Yep. No problem. Robbie.
Sorry for flooding you with too many questions. You said finalizers run as a separate process from Babe?
Yes.
grandfather-
The block production algorithm. Yeah.
Who runs the finalization process?
The validators.
Do they also do
So that yes. So validators are doing multiple things, right? So they are producing blocks and finalizing them. It's the same node. They're just so when I said separate process, I didn't mean like literally like an actual process like with its own PID and everything.
Yeah.
Like it is a separate algorithm that is run on it.
Do they get rewarded for that? Why do
It's-
they have to do that?
It's just part of what a validator does. Like in order to be a validator, you need to do both of these things.
So what if I skip one? Can I do like ding?
So like if
Slash, right?
if you don't finalize and others are finalizing, then you would be slashed.
Thank you.
Yep. Any other questions? All right. Well, again, you all have my email, Twitter. If you do want to get in touch with me, I'm happy to talk with you. And I'll be around. I'll be having some cake. So happy to talk with everyone. So Colin, thank you very much to Code and Supply for having me here.
Woo.
Yeah. Woo. Oh, we'll see. I probably haven't become. I'm still next up.